omega t be acting upon a body. Which body? That is mass body, and the motion of the body being, and the motion of the body being, motion of the body being. So if the motion will be, if you apply the force, F is equal to F naught sine omega t, the X will be, the equation for X for SHM is equal to, you know that, right? That is A sine omega t. Let us take a phase difference as -5, okay? Maybe having a +5 or -5. You have studied these things, addition of two sinusoidal waves or superposition, right? You may have omega t +5 or omega t -5. So -5 is nothing but this one. See, +5 is nothing but this one. Okay, so it starts from 0, then it is omega t minus or omega t plus 0. So if it starts early, then it is minus, right? If it starts late, then it is plus. So the curve will be like this. It is a phase difference. Okay, F. So next, this is what the displacement equation. One is for the force equation, and the second one is for the displacement equation. The work done by the force, write down, continue. The work done by the force. Which force? We have applied a force, right? If you apply the force, what happens? It moves a displacement, or the distance traveled by the body is x. If you apply the force F. Now what is work done? Work done is equal to F into x. F into x, or the displacement into the force. It is called as a work done. The work done by the force F during an interval, when the body moves through a small displacement, let us consider, will not take total distance, will have dx distance, very small distance, is given by work done is equal to. So if we apply a force F, if it moves a distance of dx, small, very small distance, then you can find out the value of work done is equal to F into dx. Very small distance is equal to F into. All of you copied? If you want to copy this figure, you can copy this, but it is not necessary. It seems we have seen many cases. We have seen the same figure, right? You can write, you can copy this, otherwise you can leave it, no problem. It is left to you. It's better to copy the figure, because if you explain everything with a figure, then we'll get a full marks. Copy it. Will I continue? Hello?
Yes.
Hello? Yes.
Yes.
Completed. F into dx, that is the force applied, the displacement, is equal to, I can rewrite this equation, F into dx by dt into dt. So I have divided and multiplied by dt. dt multiplied and dt divided. So this is what my work done equation. For a period of one cycle, one cycle, omega t varies from 0 to 2 pi, 0 to 2 pi, and therefore t is equal to t varies from 0 to 2 pi by omega. I'll tell you what it is. Copied? The last sentence. Okay, here for a period of one cycle. What do you mean by one cycle in a SHM? I can give you, see, look at this. We have a simple harmonic motion. So let us consider it is a phi is 0, okay? The curve is like the simple harmonic motion. Right? Continuous. One cycle is nothing but from here to here. It is one cycle. Right? If you mention the angle here it is pi by 4. This is pi by, sorry, this is pi by 2. This is pi. This is, what is this? This is 2 pi. Right? 2 pi. To complete one cycle, so the phase difference or the angle covered by the cycle is 2 pi. 2 pi. So this will be pi, right? This is pi. Then what about this one? What about this? Hello? Okay, so this is 2 pi. Yeah, this is pi. Half cycle, it takes pi, and this is 2 pi. Now, we have for one period, for the period of one cycle, for one cycle is this one, right? From here to here. The cycle, omega t varies from 0 to 2 pi. Omega t, this is what omega t, right? Omega t. So omega t varies from 0 to 2 pi. 0 is this one, and this is 2 pi. Therefore, t varies from this omega t. Omega t is 0 to, omega t tends to 0 to 2 pi. If you take only t is tends to 0 by t, it is nothing but 0 by omega is nothing but 0 to 2 pi by omega. So if you take omega this side, we'll get 2 pi by omega. So what is the time varies from 0 to 2 pi by omega for one cycle. Now we can find out the work done for one cycle. Because we know the range 0 to 2 pi by omega, and we know the work done equation, that is F into dx by dt into dt. That is for small distance dx. We can find out the work done for one cycle. One cycle means it is having the distance traveled by an x distance, and it is reaching to the original position. So that's why one cycle is nothing but, so if it is a mean position, this is the mean position, this is a maximum position, it moves up and coming down, then again it moves up, it will reach to this point. So this is what one complete cycle. So at this point, this is one cycle, right? At this point, now what will be the work done for one cycle, that we are going to find out. Is it okay? If you want to copy this, you can copy this. You can write these equations. Okay, next slide. Copied. Okay. Therefore, work done per cycle The previous equation, this is for work done for dx distance. We are going to take work done for one complete cycle is equal to W, it's not omega, it is W, capital W is equal to integration of 0 to 2 pi by omega. For one cycle, what is the time? It is 0 to 2 pi by omega into f into dx by dt into dt. It is equal to 0 to 2 pi by omega. Are you following or not? What is the value of f? You see the previous slide. F is equal to f naught sine omega t. F naught sine omega t into dx by dt, differentiation of x with respect to time. X is here, differentiation of x with respect to time. So if you differentiate this equation with respect to time, will have omega a into omega cos omega t minus 5, cos omega t minus 5. So here we'll have a omega cos omega t minus 5. This is what is dx by dt. Differentiation of x with respect to time. What is x? X is here. Differentiation of x into dt. Now we need to integrate this term. Is equal to here we have f naught is a constant, a is constant, omega is constant. We'll take it out. F naught omega a integration of 0 to 2 pi by omega sine omega t into here cos a minus b. Cos a minus b will gives you cos a cos b. Cos b is cos pi plus sine a sine b. It is equal to f naught omega a here cos pi is a first term. Will if you multiply this, so cos pi is a constant, you can bring it out, write down cos pi integration of 0 to 2 pi by omega. First term will have sine omega t cos omega t into dt plus sine phi. Second term sine phi is a constant, sine phi integration of 0 to 2 pi by omega. We have sine square omega t into dt. Are you following or not? What, Ritvik? Now it is 36, okay. Am I audible?
Yes, sir.
Okay. Are you following or not? Simple integration and differentiation. I'm going to simplify these equations. Okay. Okay. Next. It is equal to okay. Next. F naught omega A into cos pi integration of 0 to 25 by omega. Here sine omega t cos omega t. I'll write it here. Look at this. I have formula that is sine 2 theta is equal to 2 sine theta cos theta. Therefore, sine theta cos theta is equal to sine 2 theta by 2. So I'm going to take this term. Sine omega t cos omega t, sine omega t into cos omega t is equal to sine 2 omega t divided by 2. This term. Okay. So I'll take it as 2 sine. What is that? No, not 2. That is okay. So that is sine 2 theta. Sine 2 theta is 2 theta is nothing but sine 2 omega t divided by 2 into dt plus second term sine phi integration of 0 to 2 pi by omega. Second term I'm going to do it. Look at this. Second term I have cos 2 theta is equal to 1 minus 2 sine square theta. To 1 minus sine square theta. Therefore, sine square theta is equal to sine square theta is equal to 1 minus cos 2 theta by 2. Correct? So I'll do the same thing here. 1 minus cos omega t, sorry, cos 2 omega t, 2 omega t divided by 2 into dt. Close the bracket. Dear students, you need to practice it. There is no other method. You cannot read it and you cannot remember it. You need to do it. You'll get the problem, solve it, continue. Otherwise, it will be very difficult. You need to practice it in rough notebook. There is no other choice. Okay? Every derivations, you need to practice it. Okay. So this is what the simplification, what we have done. After the simplification, we can go for the integration. The first term integration of sine 2 omega t, sine 2 omega t, integration of sine 2 omega t. What is the integration of sine 2 omega t minus cos 2 omega t, right? Substitute the value 2 pi by omega in t, 0, 0, so cos 0 is 1, 1 minus cos 2 omega into 2 pi by omega will get cancelled, 2 will get cancelled, right? The second term we have two terms, one is half, another one is cos 2 omega t by 2, cos sine 2 omega t. So I'll write it directly. Look at this. If you integrate this previous term, we'll get, you can simplify it, you can check it. So f naught omega into a will get the first term as 0, second term as pi by omega sine pi. This is what the final answer. Final answer. Therefore, work done, you can check it, integrate it, previous equation, substitute the value 0.225 by omega, we'll get the same answer. I'll have checked, have already verified it, we'll get the same answer. First term will become 0, second term will get pi by omega into sine phi. W is equal to pi f naught a sine phi. W will get cancelled. Sorry, omega will get cancelled here. So this is what the general equation for the work done. Write down below this significance of this work done statement. If phi is equal to 0 in this equation, phi is equal to 0, then the work done is equal to 0. Phi is equal to 0, work done will become 0. It means if the force is in phase means phase angle is 0 with the displacement then the force then no work done per cycle. What it indicates, if phase angle is 0 means it starts from 0. If the force as well as x both are in the same plane or in the same phase, so let us consider red curve is for the displacement, and I'm going to take a blue curve. The blue curve is also with the same phase, no difference. Then you can say there is no work done. Work done for cycle is 0. Next, second implication, the second significance. If phi is equal to 90 degree, then the work done is, what is sine 90? Sine 90 is 1. That is, if the work done is, what is the work done state? W is equal to, phi f naught a, sine 90 is 1. That is, if the force is in phase with velocity, if the phase is in velocity or ahead of displacement 90 degree or ahead of displacement 90 degree, then the work done per cycle is then the work done for cycle is phi f naught a. If it is 90 degrees C, if this is a red curve, is a displacement curve, then angle phi is somewhere here, right? This is the curve, force curve. Then the work done will be maximum. That is the indication. This is what the work done equation. I think very simple, but you need to you should know how to derive the equations and how to integrate the equation. So there is some modifications will be there on the basis of this formula. So by that you can solve the equation. So you can mark equations here. This is what the first equation, and this is what the second equation, right? Right? Please. Copy it. And the work done equation is also very, very important question. It is asked many times in the exam. Please remember it. Next. Write down the heading, next heading. All of you copied? Hello.
Sir, let's take second page derivation.
Yes?
Second page derivation.
Second page, okay. Yeah, this one, right?
Yes, sir. No, sir, previous.
Huh?
Little previous.
Yes?
One page back, sir.
Yes?
One page back, sir.
One page back. Okay, this one, first page, right?
Yes, yes, yes.
Yeah.
Over, sir.
Okay. I hope you finished, right? Let us go to the next slide. Okay. Next heading, torsional vibration. Write down. Torsional vibration. Whatever the derivation or cases we have seen is longitudinal vibration. Right now we'll go to the torsional vibration. We have to derive the equation for the natural frequency of a torsional vibration. You know that? What is torsional vibration, right? Write down. We have seen there are three different types of vibration. First is the longitudinal, second one is a torsional, third one is a transverse, right? Transverse. So longitudinal spring mass system is the best example. Torsional vibration, if you have a disc, if you twist the disc, there will be a torsional force or the torque will be applied on the twisted disc. So it starts to vibrate. And the third one is transverse vibration. The example is cantilever beam is an example. And one more example is a pendulum, simple pendulum. Okay, torsional vibration, right down below that. If a rigid body oscillates about a specific reference axis, if a rigid body oscillates about a specific reference axis, if a rigid body oscillates about a specific reference axis, the resulting motion is called torsional vibration. The resulting motion is called torsional vibration. torsional vibration. Next, continue the sentence. In this case, the displacement of the body, in this case, the displacement of the body, the displacement of the body, the displacement of the body, in this case, the displacement of the body is measured in terms of is measured in terms of is measured in terms of angular coordinates. Angular coordinates. Angular coordinates. Full stop. In a torsional vibration problem, in a torsional vibration problem, in a torsional vibration problem, the restoring moment, the restoring moment, the restoring moment may be due to, restoring moment may be due to restoring moment may be due to the restoring moment may be due to the torsion of an elastic member, the torsion of an elastic member. Copy this figure. Do it fast. So write down below this figure, J is equal to polar mass moment of inertia of disk. M is mass of disk. W is weight of the disk. Mg. Kt is a torsional stiffness. Torsional stiffness of the shaft. Theta is angular displacement of the disk. T is a torque. Alpha is equal to angular acceleration is equal to d square theta by dt square, angular acceleration, or it is called as d square theta by dt square. Copied. Here we have theta, okay? This is theta. Is having a mass of m. Disk is having a mass of m, and the diameter of the disk or the diameter of the shaft is d. Copied. Hello.
Yes, sir.
Okay. Copy the terms also, right? Okay. I hope you finished. I'm going to compare this torsional disk. You look at this. This is the disk, okay? This disk is having a polar mass moment of inertia as J, and it is having a mass of m, and the weight is W. It is mg, and kT is a torsional stiffness. I'm going to compare this with a spring mass system, okay? This is where the spring, and we have a mass. This is m. This indicates this mass. This shaft is this shaft indicates the spring, okay? This here we are going to take K, right? So K is a longitudinal stiffness in the case of spring mass system. But here KT is a torsional stiffness. So torsional stiffness is nothing but the resistance offered by the shaft to twist it. So if you want to twist it, okay, so there will be a resistance offered by the material because of its stiffness. That is called as KT, that is torsional stiffness. So what is the torsional stiffness or the torsional force or the torque or torsional resistance by this KT? That is equal to, torsional resistance is equal to torsional resistance is equal to KT into, what is the displacement? Here in the spring mass system it is x, but why here what is the displacement? The displacement is angular displacement, correct? If you twist the disk in this direction, it moves a distance, or it rotates a distance of, or the angular distance of theta. So it is KT into theta. But here it is K into X, that is spring force, right? Spring force is equal to K into X. But here in the torsional system, it is KT into theta because the displacement is in theta angle. But here displacement is in longitudinal direction, or it is a linear motion. So that's why. So this is what the one term. Okay. Second term, here, if you twist it to an angle of theta, then if you leave it, what happens? It starts to vibrate, right? To and forth motion. It starts to vibrate, right? So it moves in this direction, again it moves in this direction, like that, it starts to vibrate, right? So after twisting it to theta, and if you leave it, what happens? It will come back. It will tries to move in this direction, correct? So it is moving with the angular acceleration. What is angular acceleration? Angular velocity is omega. Omega is angular velocity, okay? Angular velocity. So you can write it below this. Angular velocity, that is radians per second. Here it is radians per second square. So if it moves with angular acceleration, d square theta by dt square, that is alpha, then it is having its own mass, right? mass with angular acceleration, that will gives you inertial force, correct? Inertial force, or this inertial force is equal to mass into angular acceleration, that is m into alpha. But here you cannot take m. Instead of taking m, we are going to take it as j, that is polar mass moment of inertia. You cannot take it as a mass, polar mass moment of inertia. But in this case, we are going to take it as m into a, inertial force. So if you pull it down, if you leave it, it moves upward direction with acceleration a, mass into a, that will gives you the inertial force. But here j into alpha will gives you the inertial force. So that is the difference. We have two terms. One is kt into theta. Second one is j into alpha. If you understand this concept, the derivation is very easy. Is it okay? So I have compared spring mass system with torsional system. So the term is different, but the concept of deriving the equation is similar. Is it okay? So I'll do it. I'll go to the next slide. If you want, you can copy the spring mass system and you can compare the terms. First term, torsional force and spring force. So here kt into theta, but here it is k into x. You can easily remember if you copy this, okay, in a note or a rough side, okay, rough work, you can do it. But here inertial force m into a in the spring mass system, but here it is j into alpha. So that you can do it. If you want, you can copy this, otherwise you can leave it, no problem. If you understood the concept, no problem. Okay, let us go to the next slide. Hello. Shall we go to the next slide?
Yes, sir.
Okay.
Yes, sir.
Okay. So next is write down. Suppose a system having a disk. Write down. Suppose a system having a disk. Suppose a system having a disk connected to the shaft. Connected to the shaft. Twisted by an angle theta. Twisted by an angle theta. Twisted by an angle theta, as shown in the figure. As shown in the figure. As shown in the figure. So I'm going to take one more figure. So this is what is the screen is visible. Write down below the next line. Below that, when at any instant, the rotor occupies a position theta. A rotor occupies position theta with reference to the equilibrium position. With reference to the equilibrium position, the torque acting on the rotor, through the twisted shaft is twisted shaft is kt into theta. That is kt into theta. That is a torque or torsional resistance. Okay, kt into theta. Next line. The torque resisting to the applied torque. The torque resisting to the applied torque is opposite to the direction. The torque resisting to the applied torque is opposite to the direction, that is J into alpha. J into alpha. Next line, from Newton's law of motion, or it is called as equilibrium method. Equilibrium method. Therefore, summation of all the moment is equal to 0. What is the summation of restoring torque plus accelerating torque? Accelerating torque is nothing but inertial torque is equal to 0. So in the previous case, what we have done, spring mass system, spring force plus inertial force is equal to 0. Here it is restoring torque. It is kt into theta. Acceleration torque, it is J into alpha. It is equal to 0. Now look at this. If you twist it to an angle of theta, that is twisted angle, it is in this direction, right? If you twist it, what happens? There will be resistance offered by the shaft, right? This is the shaft. So there will be resistance offered by the shaft to twist it in this direction. So that resistance is in this direction, that is kt into theta. That is opposite direction. And if you twist it to angle theta and if you leave it, what happens? There will be a inertial torque that is opposite to the twisted direction. So this inertial torque is also in the same direction, that is J into alpha. J into alpha. Both are in the same direction. Please remember. In the spring mass system also we have done the same thing, right? So I can show you. Look at this. So this is the spring mass system, right? M. So if you pull it down, what happens? So it will reach to somewhere here. The force, the spring force is K into X. It is upward. Then accelerating force, it is also upward. That is M into A, correct? So here also KT into theta, clockwise direction. M into A. But here M into A, instead of M into A, here we have J into alpha. J into alpha in the same direction. Both are in the same direction. So we can compare this with the spring mass system. Only one force, that is M into G, is downward. That's all, correct? But here no matter of weight, right? We are going to neglect it. So two forces. So restoring torque. What is restoring torque? That is kt into theta, positive, okay, because it is clockwise, plus acceleration torque, that is J into alpha, also positive, is equal to 0. Therefore, I'll rewrite the equation. Is there any doubt in this equation? Why it is kt into theta is clockwise? Because the twisting is in counterclockwise. If you twist it in the counterclockwise direction, there will be resistance to twist, right? That will be in the opposite direction, clockwise. That is kt into theta. That is a restoring torque, or it is called as resisting torque. Next, accelerating torque, or it is called as inertial torque. If you twist it to an angle theta, then if you leave it, what happens? It will move. It will tries to move it in the opposite direction, clockwise direction. So with acceleration, angular acceleration, that is J into alpha. J into alpha. Is it okay? Both are positive. Is equal to 0. There is no other moment here. So in the equilibrium position, 0. Next, I'll rewrite the equation. Alpha plus kt by J into theta is equal to 0. Equation number 1. We have another 1 minute. Do it fast. See, it is same as what we have in the spring mass system. We have spring mass equation is equal to K by M into X, right? Is equal to 0. It is similar. Instead of A, right? Linear acceleration, we have angular acceleration. K by T, kt here, M badlige, we have J. And X is the displacement. Here it is theta is the displacement. Same equation we'll get, right? Okay. Next is very simple. Next is just keep on comparing with the spring mass system. We'll come to know why it is like this. Is it okay? Next equation. For SHM, we have an equation for SHM alpha plus omega n square into theta is equal to 0. That is equation number 2. Why we have taken alpha plus omega n square is into theta is equal to 0? Because we have for spring mass system, we have equation. What is SHM equation? A plus omega n square into x is equal to 0. I have taken the same equation, but here I have taken angular acceleration. Here we have theta. That's all. Compare equation number 1 and 2. Copy this. Time up. Do it fast. Copied? Copy the figure also and this note also. Rest all you can write it. Copied? Hello?
Yes, sir.
Let's go to the next slide. Okay. So compare. What is that? Omega n square is equal to kt by j. Therefore, omega n is equal to square root of kt by j. Correct? kt by j. Therefore, Fn natural frequency is equal to omega n by 2 pi is equal to 1 by 2 pi into square root of kt by j. That is natural frequency. So time period is equal to Tp is equal to 1 by Fn is equal to 2 pi into square root of j by kt. How do you find out the value of kt? You know the torsional equation, right? T by j is equal to g theta by L is equal to tau by R. This is the torsional equation for the torsion, right? Therefore, kt is equal to, what is kt? kt is equal to T by torque by theta. It is equal to, what is the T by theta? Here T by theta. Theta, if you take this side, we'll have T by theta is equal to Gj by L. Correct? Gj by L. You can find out the value of k theta if you know the value of torque and theta. Or G, that is a modulus of rigidity, polar moment of inertia, L. What is J value? G into J is pi d square by 32 ala divided by L. This is only for your reference. You can go through the equation, torsional equation. You might have studied in MOM. Correct? that is kT. Polar moment of inertia J is equal to pi d square by 32. D is the diameter of the shaft. Copied? Hello?
Yes, sir.
Right now it is 37. Well, I was taking attendance, it was 33. Okay, thank you. Join.